Hello students, so today we'll be seeing about the last topic of Unit 5. So we'll be seeing about ERP systems and MES systems. So already you know what is meant by ERP and MES. So we'll be integrating these two systems and we'll be seeing what is done in IIoT with these type of systems. So first we'll see what is meant by MES systems. So basically if you want to know about MES systems, it's nothing but it's considered to be manufacturing execution system which plays a vital role in digital platforms. So this oversee and manages the entire production life cycle, and we'll be having some raw materials that will be having some information. So raw materials that take some information for the delivery of finished products. So these systems provide real-time monitoring. It also provides documentation and control for various manufacturing operations. So these manufacturing operations ensures that every step in the transformation process is tracked and it is optimized and recorded for quality and efficiency. If you want to see some of the basic MES functions, it is considered as the nervous system that connects the brain, that is ERP, with the organs, we call it as IIoT devices. Okay, so MES functions as the nervous system. So it actually connects the ERP with the IIoT devices. So IIoT devices is called as organs, and ERP systems are considered as the brain, or it makes the connection. So IIoT devices collects raw data from physical assets. So it acts as sensors that transmit information about the state of production. So MES is considered as the nervous system. So it receives this raw data, it processes it, and it has some operational control and task execution. So with this thing will be transmitting aggregated and meaningful data to ERP, which acts as the brain, making a strategic decision based on this information. So this representation emphasizes that MES is not an optimal add-on, but it acts as a critical component. Okay, so it effectively operates the entire manufacturing ecosystem. So, whenever you consider without MES systems or ERP systems, it would be blind to actual shop floor conditions, and it would not have access to the detailed and up-to-date operational data. Without these information or vast amounts of data generated, the IoT devices would remain unprocessed, and it is unsuitable for operational control, and it turns potentially valuable information into the noise. So thus MES system acts as an active intermediary that interprets and or coordinates and manages information between enterprise strategy and shop floor execution. So whenever you consider smart manufacturing, it is not just of disparate technologies, but actually it is considered to be a holistic ecosystem where we can consider machines, people, and data that are integrated through digital technologies. So whenever you integrate all these technologies with the help of IIoT, you will be integrating all this. So this interconnectedness not only enhances efficiency, but also has some flexibility, but also significantly increases productivity, improves quality, and it also has some competitive positions in the market. So with the integration of MES and ERP systems, IIoT creates a continuous flow of information. So that's all about the introduction about MES. So moving on to the ERP systems, so this integration significantly improves the decision making. Okay, so when you consider ERP systems, these are integrated software platforms. So it is designed to unify and it is used to optimize. Okay, so when you say consider ERP system, it is integrated software platform which is designed to unify, and it is used to optimize an organization's core operations. So operations can include like finance, human resources, manufacturing, supply chains, sales, and other activities in the industry. So by consolidating all data across departments, ERP systems offer a centralized real-time view of business activities. So this enables the information of decision-making process, and it serves as organization single source of truth. Okay, so so that's all about ERP systems. So if you want to know in detail about ERP systems, so it manages the resources of the entire organization. As I told you, it covers various fields, and it is used in manufacturing processes also, and it is used in supply chain management and other activities. So ERP system is very crucial for achieving product quality goals, and it is also used in effectively managing asset utilization, and it controls overtime cost. So it provides end-to-end delivery or end-to-end inventory control. So by manufacturing these stock moments, identifying performance of various products, and it also manages other individual tasks in the industry. So ERP also focuses on creating and managing enterprise-wide schedule. So like production planning, material usage, delivery, shipping, and overall business and business data gathering. So it can be used as the organization's brain, determining its overall direction and strategy. So next we'll be learning about the challenges and consequences of isolated operations. So you have understood the concept of MES, ERP, and IIoT. This makes us to understand the significance of seamless integration. So we define the roles and functionality of each component like MES, ERP, and industrial IIoT. Uh, so moving on to the challenges part. So at the ERP we have the enterprise level. In IIoT we have data collection, connectivity, and other technologies. And when considering the comparison, we will be comparing with MES, ERP, and IIoT systems, where we can compare various parameters. And moving on to the challenges and consequences of isolated operations. First, it is considered to be the conventional manufacturing practices. So it is oftenly used in disconnected information ecosystem. So we have some systems like MES, ERP, and IIoT which can operate in isolation. So this architecture gives some effort to achieve operational excellence by creating barriers to data flow, collaboration, and responsiveness. So when you consider MES implementations, in particular, we can say it often struggles with issues such as inconsistent data, complex system integration, and fragmented visibility across production processes. So all these consequences of isolated operations are diverse and are considered to be negative. So there is lack of data accuracy and real-time visibility. So when you consider the lack of data accuracy and real-time visibility, it considers shop flow data that cannot flow freely into the enterprise systems. Uh, so this manages some integration issues of MES and ERP systems. So this leads to the outdated or inaccurate information for decision making. So this makes it difficult to monitor the entire progress. So there will also be some bottlenecks and other dynamically we have to change some schedules. So for example, we can say production delay on the shop floor may not be immediately reflected in the ERP. So this can lead to some incorrect delivery schedules. So moving on to the next point, we can discuss about slow reaction to market changes. So isolated systems do not allow quick responses. So quick responses is needed here. Uh, so do not have some quick responses. So so the market variations or market parameters can fluctuate, and there will be changing requirements as information does not circulate freely between design, planning, and execution levels. So this is considered to be a challenge over here. So moving on to the next challenge, we have increased manual data entry and errors. So if you consider manual data entry, there is some miscommunication or unintegrated systems that lead to redundant data entry, and this increases the likelihood of human errors. So if there are errors present in this way, so it considerably reduces the overall efficiency, and it also increases the cost. So next, moving on to the next challenge, we'll be seeing about hindrance to a digital transformation. So here the systems are not designed for integration. So sometimes it is decentralized, and new technologies hinder a manufacturer's ability, and there are some challenges in industry 4.0 considering the IIoT capabilities. So this operational inefficiency and other things will hinder the digital transformation. So if you consider other challenges like operational inefficiency and lack of traceability, uh, we can consider examples like MES that leads to delay in data collection and analysis. So if there is some delay or delay in data collection and analysis, it makes difficult to obtain timely, and decision making is also a little bit difficult. So this part results in less efficient operations. It also increases waste, and higher cost is also possible here. So basically it becomes difficult to maintain fully traceable and quality control without an integrated system, so which is critical for compliance and rapid problem resolution. So we also have some technical complexity challenge. So this challenges include incompatible hardware and software, so which complicates integration, and we have some information silos that hinder real-time insights and decision making. So moving on to the next part, so there is lack of integration that creates a deep information gap between the upper and lower management levels. So this operating at the strategic level, ERP systems lack detailed and up-to-date shop floor data for accurate planning and forecasting is needed. So at the same time, we can consider MES systems that manages operations on the shop floor, so that cannot make decisions fully. Which is aligned over business goals without ERP context. So when you consider IIoT, it generates vast amount of raw data. So this widens this gap, and it uses adequate MES and ERP systems. This data remains unprocessed, and it lacks some context. So this turns potentially valuable signals into unusable noise. So thus leading to integration becomes not just an improvement, but it's considered to be a fundamental requirement for informed decision making at all management levels. So without this ERP level, decision becomes a risk, and operational actions on the shop floor may not align with the business goals. So these are the challenges involved here. So next we'll be learning about integration meets the demands of modern manufacturing. Okay, so here you will be learning about MES ERP IIoT integration. So it's a direct response to the demands of Industry 4.0, and there are some key factors that can be considered. So, realizing IIoT potential. So here it considers integrating IIoT systems with MES equipment. So this is considered to be a game changer for the Industry 4.0. And here we will be using IIoT sensors, which generates real-time data. So it provides deep insights into the manufacturing processes. So here when you consider all these information and further processing, this enables a shift from manual data collection to automated and contextualized data. So when you consider modern MES systems, they are critical in Industry 4.0, utilizing the IIoT enabled production environment. We have some integrated M2M communication, so machine to machine communication. So this integrates MES with IIoT platforms. So this can ensure seamless communication. It significantly enhances the process automation and the overall efficiency. So, when you consider AI for predictive analytics and optimization, so AI is integrated with MES. So it offers powerful capabilities, including predictive analytics to anticipate equipment. Um, uh, uh, so and it so it includes predictive analytics to anticipate equipment failures, and it also considers automated production scheduling based on demand forecasting. So anomaly detection can also be considered here on production lines, uh, while uh, while which it can also reduce material waste and cost. So along with the AI powered MES systems, it considers manufacturing analytics to a prescribed level, which also includes predicting all the actions. We have mission-to-mission communication, which integrates MES and IIoT platforms, which ensures seamless communication with the increases automation and the overall efficiency. So when you consider all these things, you can also consider AI for predictive analysis and optimization. So this can help with the prescriptive level, predicting with predicting what will happen, and it will recommend actions to optimize the outcomes. So based on digital twins also, it can create IIoT data which allows manufacturers to simulate and optimize production scenarios. So this can process all the actual information. So these models can improve resource allocation, energy efficiency, process planning, and also it helps in managing all the disruptions. So when you consider all these integration, so we have to change, and there will be a lack of user adoption, which will often arise when implementing new technologies. So when systems work together, it significantly simplifies workflows. It can also reduces the need for manual data entry, and it lowers the number of errors, and it makes the technology less burdensome, and it makes more user friendly. So MES interfaces can be used along with augmented reality for training, and it can also be used for troubleshooting purposes. So successful integration is basically improved with the technical performance, and the organization have a trust in data and the systems, and it encourages the adoption of new technologies. So this is critically important for long-term success of digital transformation. So there are various technologies we are going to adopt. So when you consider this comprehensive benefits of MES and ERP IIoT integration, so here we have MES ERP integration, which optimizes workflows, and it eliminates the redundant processes. So it reduces the manual data entry errors. It can lead to substantial efficiency, and it gains cost, and it can considered for various applications. So when you consider, for example, like food processing company, so it can save up to $1 million annually by automating data transfer between MES and ERP systems. So this can reduce manual intervention, and it can reduce the associated errors. So consider consumer electronics manufacturer, for example, they can integrate IIoT to monitor and optimize its productions line. So they can identify the bottlenecks, and they can focus on the streamlined operations. So this can result in 20 percentage decrease, or 20 percentage increase in production efficiency, and there can be 10 percentage reduction in material waste. So altogether, to 80 percentage of MES users report 20% increase in operational efficiency. So after adopting Industry 4.0 principles. So when you consider improved quality management and compliance, so we can consider MES, where detailed quality directly uses production, and while ERP aggregates this data for reporting. So this integration can ensure full product traceability, and it simplifies stringent regulatory standards. For example, when you consider a pharmaceutical manufacturer, which can integrate MES and ERP to monitor batch quality and automatically generate complaints reports for regular regulatory audits and so on, they can significantly reduce the risk of penalties. So in case a medical device manufacturer can reduce reject rates from 30 percentage to 20 percentage, 30 percentage to 2 percentage. So this can be done by implementing a real-time monitoring system that can be integrated with the ERP systems. So when you consider MES, it also provides automated inspection using machine vision technology, and machine learning algorithms are very fast and accurate. It can detect some defect detection. So these systems provide production processes. It can verify logging every step. So it also helps in businesses to regulatory requirements, and it can ensure high product quality. So next we'll be focusing on optimized supply chain and inventory management. So when you consider this supply chain and inventory management, so the integration allows MES to track material usage and inventory levels. So it is all done in real-time environment. So the ERP uses this data for inventory planning and so on. So there will be a synchronization of operation will be done. So this synchronization prevents overstocking and shortages. It also optimizes working capital, and it can reduce carrying cost. So for example, like global automotive company can reduce inventory holding cost to 15 percentage. So by integrating MES and ERP systems, which can allow them to align raw materials purchases with actual production needs. So you can consider IIoT, which can provide end-to-end visibility, so across the entire supply chain. So this helps to track the raw materials. So there will be so many work in progress, and there can be finished goods in real time. So these also reduces the need for buffer stock, and it can improve the order fulfillment. So when you consider predictive maintenance and asset management, IIoT devices continuously transmit data from machines to MES systems. So this type of action enables the predictive maintenance and real-time optimization. So data-driven predictive maintenance can reduce mission downtime by 30 to 50%, and it increases mission life by 20 to 40%. So specific examples we can have like automotive parts manufacturer who can reduce unplanned downtime by 30%. So there are other operations which can have extended equipment operation life by 15%. So these all things can be done by predictive maintenance system. So similarly, we have it for a large scale food processing company where we can reduce maintenance cost by 25% and unplanned downtime by 35%. So how we can reduce this is by utilizing IIoT sensors to monitor refrigeration units. So these are all the things you have learned under comprehensive benefits of MES, ERP and IIoT integration. So moving on to the next part, we have two things: risk reduction and innovation stimulation, and then we have accelerated product development cycles. So when you consider risk reduction and innovation stimulation, so it has integrated MES with IIoT systems. So predictive maintenance and supply chain management allows manufacturers to optimize production processes, and it can significantly reduce operational risk. So when you consider this type of integrated systems along with the MES, ERP and IIoT integration, this enhances the agility and it increases the responsiveness to market changes. So these changes can enable faster decision making, and it can consider quicker reactions to demand fluctuations and so on. So AI with the MES enables truly adaptive manufacturing where production parameters are automatically adjusted. So everything happens in real-time environment. So MES ERP integration creates a single source of truth. So it provides a single source of truth by providing transparency for regulatory actions, facilitating audits, and it can be used in minimizing non-compliance risk and so on. So when you consider in digital twin technology, it can use IIoT data which simulates and optimizes production scenarios without real-time disruption, and it can also enhance or improve resource allocation, energy efficiency, and process planning. So when you come to the last part, it's accelerated product development cycles. So here you will be learning about the integration of MES and ERP along with product lifecycle management. So we will be integrating three systems. MES is integrated, ERP is integrated along with PLM. We call it as product lifecycle management. So these systems are considered to be closed loop between design, production, quality, and resource management. So it provides a single source of truth for all stakeholders. So when you consider product lifecycle management, so users can easily send engineering changes to the shop floor, and all the information about resource modification is automatically sent to ERP. So this can avoid tedious data re-entry. So this significantly improves quality and change management across the entire value chain and product life cycle. So here we have big data analytics can also be done. So which results from this integration and can reduce product development, uh, and the cost is as much as 50%. So this is all about comprehensive benefits. Um, and next we'll move on to the next part where you will be focusing on technical aspects and architectural models of integration. So there is also some comparison between MES, ERP and IIoT integration. So based on operational efficiency, we have production efficiency is increased, and the quality improvement is considered to be 20%. And there are so many parameters can be considered, for example, like quality management, inventory management, predictive management, and product development. So next we'll move on to technical aspects and architectural models of integration. So here we'll be considering the integration of MES, ERP and IIoT systems. So first here we'll be having data transfer mechanisms and protocols. So protocols play a vital role. So IIoT platforms play a key role in enabling communication between industrial systems. So there is standard exchange of data that can be done by various protocols. We can be doing all these data exchanges like OPC UA. So exchange of data can be done by MQTT, REST API, and other protocols like PLC, OLE, and so on. So we'll be learning about the data transfer mechanisms. So this enables the communication between industrial systems. So we should have a deeper understanding about all these protocols. So when you consider OPC UA protocol, so this protocol is widely used for vertically integrating the machines with MES, ERP, and SCADA systems. So when you consider this protocol, it ensures secure and reliable data transfer in an industrial environment. Next, moving on to the other protocol, we call it as MQTT, is Message Queuing Telemetry Protocol. So this MQTT is considered to be a lightweight messaging protocol. So all the MQTT is suitable for unstable networks. So it buffers data in a broker, and it ensures reliable delivery even with communication interruptions. So it forms the basis of many industrial data streaming platforms. And moving on to the next part, we have REST API, where it's considered to be representational state transfer application programming interfaces. So you would have learned about REST API, but I'll tell you again. So REST API is widely used for cloud integration. So it provides secure connections via TCP/IP, and it can be also used along with the O authentication, that is 2.0, and it allows systems to exchange data in a controlled and consistent manner. So that's the advantage of using REST API. And moving on to the other protocols, we can have some integration that can also be achieved using machine sensors. So along with other protocols like programmable logic controller interfaces, communication protocols like OLE. OLE is called as object linking, object linking and embedding for process control, and industry standards like SECS or GEM and Euromap 77. So these all protocols can be considered. So the variety of interface standards in manufacturing, like we can use protocols like Profibus, Profinet, Modbus, OPC UA, REST, ActiveMQ, SECS or GEM, Euromap 77. All these protocols indicate different protocols where we can use by machines and systems. Okay, so IIoT platforms act as universal translators, so they can convert legacy protocols into open standardized one, allowing everyone to speak the same data language. So this is actually fundamentally important for integration technique, and the manufacturer must invest not only in end systems, but also they can invest in intermediate platforms, so that can ensure linguistic compatibility, especially when dealing with heterogeneous equipments and legacy systems. So here so we have learned about the different protocols here. So next we'll be seeing about the role of IIoT platforms and the unified namespace concept. So here in an industrial data streaming platform, they serve as a backbone for real-time industrial data architecture. So they enables every asset, system, and application to participate in a single, accessible, and structured architectural pattern for integrating industrial data. So it combines the capabilities of IIoT platforms. So data streaming is possible, standard data models, standard APIs, and data catalogs, everything are considered here. So it creates a decentralized data architecture, so where all the systems can publish and subscribe to information. So already you have learned about publish subscribe model. So to information without requiring direct point to point connections, it can simplify the data flow across the enterprise. So when you consider MES and IIoT connected machines, you can generate a vast amount of data, reaching up to a terabyte. Uh, so daily we can use that quantity of data. So UNS acts as a architectural response to this data explosion, and it considers the complexity of integration. Here we can consider UNS, where we can have strategic choice for companies aiming for long-term scalability in their digital architecture, and for the effective use of AI and machine learning. So this helps to reduce the risk associated with future systems, which can be used for upgradation and replacement. So here we will be considering some role of IIoT platforms with with three standards. So first is based on connectivity and protocol conversion. So this particular conversion brings the bridging legacy and PLC protocols with open IIoT standards such as OPC UA and MQTT. There are also some data services like tagging data to access, normalization, so which depends on standardizing units, timestamps, and hierarchies, and so on. Transformation is possible, and data quality management, everything it can be considered in data services. And when you consider northbound integration, there are connectors like MES, ERP, CMMS, Historian, and Cloud Analytics, which shortens time to value. So all these industrial data streaming platforms serves as a backbone for real-time industrial data architecture. So this enables every system, every application to participate in a single accessible and structured model. So we have MES and IIoT connected machines that can generate vast amount of data, so reaching up to a terabyte daily, right? So this is all about the role of IIoT platforms. So next we'll be learning about the integration with the legacy systems and cloud uh, solutions. So when you consider this type of integration, implementation of challenge is integrating MES with complex existing ERP, SCADA, and PLC systems. So there are many operating companies that can have legacy systems that are very difficult to integrate with modern MES. So challenges include like it is incompatible with hardware and software, which complicates integration, and we have some real hindrances like information silos and so on. So there are also issues related to the lack of standardized data formats in industrial ecosystems, and there are some difficulties in real-time data synchronization. So cloud solutions are increasingly used nowadays, and so to overcome all these challenges, we'll be using this cloud solutions. So cloud platforms provide scalable and cost-effective MES, and ERP systems. So centralizing operational data, and it reduces the reliance on expensive on-premise infrastructures can be done. So there can also be used via hybrid architectures, so which can reduce the cost by 25%, and it can increase productivity by 20 to 30%. So there are also some risks related to the standardized data formats in an industrial ecosystem. MES modules can also be deployed in various environments, and it can provide manufacturers with migration paths. So this is all about the integration. And moving on to some case study of production optimization, quality management, and supply chain synchronization. So we have production optimization, quality management, predictive maintenance, and supply chain management. So we'll be having all these case studies. So uh, when you consider this, so this provides the versatility of MES, ERP, IIoT integration, which is evident. So when you consider this type of analysis, it shows the basic concepts. So there is a need for individual adaptation of solutions to the specific requirement for each industry. So when you consider a production optimization, so it allows energy consumption, identifying inefficiencies, and optimizing resource utilization. Moving on to quality management, so a medical device manufacturer can reduce reject rates from 30% to 2%. So that can be done in quality management. In predictive maintenance, we can consider unplanned downtime by 30% and extended equipment operational life by 15%. In supply chain management, IIoT provides end-to-end visibility across the entire supply chain. So this helps to track all the raw materials. So it also helps in work progress, and it focuses on the finished goods in real time. So this supply chain management reduces the need for buffer stock, and it improves the order fulfillment. So integrating the MES and ERP systems, which is allowed with the global automotive company to reduce the inventory holding cost by 15% by aligning raw materials purchases with actual production needs. So this is about the case studies of uh, different use cases based on production optimization, quality management, and supply chain synchronization. Thank you, students. So your portion is completed till fifth unit. Thank you.